Hi, this is Gabriella Macias with the third FRQ from BC Calculus 2007. FRQ, you're going to need to know your baby unit circle, polar equations, and some knowledge about particle motion, and the area for a sector of a circle, and the limacon. So for this one, that you'll be working with a polar graph instead of the Cartesian plane. So your coordinates are no longer x and y, but rather r and theta. Remember r being how far across, and theta being your degree around the baby unit circle. So they give you some pretty important information to begin with. They give you the graph r equals 2, which is this circle with a radius of 2, and r equals 3 plus 2 cosine theta, which is this weird lima bean tomato butt-shaped graph. It also tells you the intersection points, 2 pi over 3, which is right here, and 4 pi over 3. Alright, so for part A, it says let R be the region that is inside the graph of R equals 2, and also inside the graph of R equals 3 plus 2 cosine theta, which is the shaded figure right here, and define the area of R. And for this, you're going to need two equations, the area of a sector of a circle and of limacon. So you're first going to need to find the sector of a circle. And what that means is you're going to find the part that's not part of this weird part right here. So you're going to find from intersection point 2 pi over 3 to 4 pi over 3, this Pac-Man, an inverse Pac-Man looking shape right here. So what you're going to do is you're going to take 4 pi over 3 minus 2 pi over 3, so that's going to give you this part right here. And that's going to be 2 pi over 3. But that gives you the empty part, but you want the Pac-Man shaped part. So the area of the whole circle is 2 pi minus 2 pi over 3, and that is 4 pi over 3. This 4 pi over 3 is going to be equal to your theta. That's part of this equation right here. So this is your theta, 4 pi over 3. So to plug this into the formula, area equals 1/2 theta, which is your 4 pi over 3, times your r squared. And in this case, your circle is r equals 2, so that's 2 squared. So now the area of that sector of a circle is going to be 2 pi over 3 times 2 squared, which, as you see here, is your first point from the equation, the area of a sector of a circle. But you're not done with that yet. You still need the area of the limacon. So what you're going to do is the area equals 1/2 the integral theta 1 to theta 2, the intersection points, which you already know. Thankfully they gave it to you. 2 pi over 3 to 4 pi over 3. 2 pi over 3, excuse my handwriting. 4 pi over 3. And since you're finding this graph, the weird looking one, you're going to use the r that's associated with this curve. So r in this case is 3 plus 2 cosine theta squared d theta. And the complete part of the area, you're going to add the sector of a circle, which is 2 pi over 3, 2 squared, plus 1/2 integral 2 pi over 3 to 4 pi over 3, 3 plus 2 cosine theta, I'm just copying it from up here, d theta, and that will equal your area. And when you plug it into your calculator, you get 10.37, this weird number right here, which gives you your full points for A. Part B, a particle moving with a non-zero velocity along the polar curve given by the equation has a position xy at time t with theta equals 0 when t equals 0. Yada yada. Find the value of dr dt at theta equals pi over 3 and interpret your answer. So the key word for this section is velocity. And when I hear velocity, I think the first derivative, and that's exactly what you have to do. So you take your r, your equation, r equals 3 plus 2 cosine theta, and you take the derivative. dr over d theta equals 2, remember this is negative sine theta. So dr d theta equals negative 2 sine theta. So it gives you this information. Dr d theta is equivalent to dr over dt, which is nice because it asks you to find the value of dr dt at theta equals pi over 3. So all you do is go to here, and since this is equivalent to dr over dt, you plug in your theta value of pi over 3. So negative 2 sine of pi over 3. And from your baby unit circle, you go to pi over 3. And your sine value at that is square root of 3 over 2. So negative 2 times the square root of 3 over 2 gives you your answer. So that first value, your point for the first point in that equation, but the second point is a little more difficult. It's your interpretation. So what you're going to do is you're going to say, okay, dr over dt is what I have here. And that value at pi over 3 is a negative value. It's equal to negative 1.732. But what does dr dt represent? R in this equation is your radius of a circle. And if the rate in which the radius is changing is a negative number, and r is, positive in itself, it's greater than 0, you know that your radius is actually decreasing. And if the radius decreases in relation to the origin, it's getting smaller, the radius is getting smaller, so the particle is actually moving closer to the origin in this case. And that interpretation gives you your second point. Part C, it says, for the particle described in B, dy dt equals dy d theta, find the value of dy dt at theta equals pi over 3, and interpret your answer in terms of the motion of the particle. At first, this seems kind of difficult, because you look at dy over dt, and you don't see a y or an x in any of your r polar equations. So you're like, how do we change it into, an equation that has y in it, so I can take the derivative of it? But you have your handy-dandy polar equations right here. So if you want y in this instance, y equals r sine theta. And you're given your r, your Lamichon part, which is simple substitution, 3 plus 2 cosine theta from the above graph, and sine theta. What to do now is take the derivative of this value. So y prime, and you could do the product rule, but I'm a little bit lazy, so I'm going to plug it into my calculator. This is a calculator problem, so that's no big deal. 3 plus 2 cosine theta times the quantity of sine theta at the value, of course, of pi over 3. So second pi by 3. And that will give you 0.5. The last part, this really tricky last point. This is your first point, changing it, and then your value is the second point. So dy d theta, is 0.5. And it gives you dy d theta is equivalent to dy dt. So you're going to use this, your dy dt equals 0.500. And if you know that this dy dt is a positive value, and that your y initially is greater than 0, this gives you important information about the particle motion. So you really have to use your prior knowledge about the functions of certain graphs at this point. So you know y is greater than 0, so that kind of eliminates that part of the graph, and dy dt is your growth, your rate of increase, and it's positive. So you know that whatever your function is, it's going to increase. And actually this means that you're slowly going to move away from the x-axis, this whole origin, because you're going to gradually increase. And that gives you your final point for C. Alright, so that pretty much sums up A, B, and C. I hope you guys enjoyed the video, and good luck with your calculus.